Okay, so today we're going to be doing this problem of basically we're given a graph, and our goal is to figure out what the equation is of this graph. So the picture is kind of blurry and fuzzy because it was taken from a phone, but the essentials are right here. So we have two vertical asymptotes here. One is at x equals 0, and the other one at x equals 3. We also have a horizontal asymptote at y equals 0. And we're also told that a hole or a removal discontinuity occurs at 1, 2, which is somewhere around here. Now, again, we're trying to figure out what the equation is and back calculate, and then we'll use Desmos to verify based on that equation that we find to see if we actually get the same graph as kind of seen here. Okay, so what do we do? Well, what I would do is start off with the easiest part, right? Which is, okay, vertical asymptotes. What do we know about vertical asymptotes? Well, let's just say that our function is f of x. We know for sure that vertical asymptotes happen when the denominator is 0. So in this case, we know that the denominator is 0 at x equals to 0 right here, and x equals to 3. So if we work backwards, we know if x equals 0 and x equals to 3. So we reverse it. Well, that stays the same, right? But this is now x minus 3 equals 0. So the denominator now is x and x minus 3. Okay? So that part is out of the way. Now, the horizontal asymptote doesn't really help us here because it's at the baseline of 0. So we don't have a plus or minus shift on the vertical shift. So that is kind of useless. All right. Now we're going to use the information for the discontinuity, right? The removal discontinuity, also known as a hole at 1, 2. So if you know anything about how holes happen, it happens when we have a rational where the numerator, a binomial term on the numerator cancels out another binomial term on the denominator. So for example, if we have something like x minus 3 times x plus 5 over x minus 3 times, let's say, x minus 5, well, here we have a discontinuity or a hole because x minus 3 and x minus 3 here, both in the numerator and denominator, they cancel each other out. So whenever we have this type of behavior, when you could cancel them out like that, that's when you know there's a hole. And in this case, in the problem, the example problem that I gave, the hole happens at x equals to 3 because you solve x minus 3 equals 0, and then ultimately solve for x, you get x equals to 3. So we're going to reverse engineer it in the same way here. So we are told that our hole happens at x equals to 1. So x equals to 1, go backwards. That means we have an x minus 1 that gets canceled out. So we're going to add an x minus 1 here. Okay. X minus 1 up top. So far, so good. But we're not quite done yet. Okay. So the last piece that we have to put together here is we are told that x equals to 1, we should get a y value of 2. Well, the only way to do that is let's just assume that we have a multiplication factor of an unknown variable called a. Okay. And if we plug in the coordinates of 1, 2 into our equation, we should be able to obtain what the coefficient of a is to satisfy our equation based on this boundary condition. So using substitution, f of 1 is going to give us 2. Let me just shift that down for a bit. So 2 is equal to 1 minus 1 is 0. Oh, that's right. Well, they cancel out, don't they? So yes. Let me do this on the fly. So What should I do? What should I do? What should I do? This just simplifies to a over x times x minus 3, right? Because this part cancels out this. Now, obviously, if we plug in 1 right away, then this is 0, 0 over 0. Bad things happen, or weird things happen, I should say. So let's just avoid that, get that out of the way. Now that we have this form, we say, okay, 2 is equal to a over 1 times 1 minus 3. This gives us 2 equals to a over, basically that's a negative 2. So ultimately a is equal to negative 4. And then our final function is negative 4 times x minus 1, x minus 3 times x minus 1. Okay. Apologies for the sloppy handwriting. But so typically we'd be done by now if this is all the question asks for. But now I want to make sure that, hey, if I put this into a graphing calculator, or in this case Desmos, are we going to get the same picture with the end behaviors and everything as we see here? Well, let me just distribute everything and then plot that in. So we should get negative 4x plus 4 up top, and then x squared, that is a minus 4x plus 3 equals to negative 4x plus 4 over x cubed minus 4x squared plus 3x. Okay, so this is our final form that we're going to plug into Desmos and double check on the next slide. Okay, so as you can see, we're on the next slide, and I already have inputted the equation on the left-hand side. And on the actual grid, you could see that it's very similar. Actually, it should be exactly the same as the original problem. So let's take a look here. We still have the horizontal asymptote at the x-axis. Okay, we have the vertical asymptote right here at x equals to 0. So far, so good. And it looks like we have that second vertical asymptote right here at x equals to 3. So far, so good. So the only thing left to check is to make sure that we have the hole, right? Which happens at 1, 2. So if I'm able to zoom in here, bear with me. Okay. Let's see if I could get this. 1, 2. So if you notice right here, oh, can I stop it? All right, it's not liking it. Right there. 1, 2. I don't know if it shows up on the screen or not, but it'll show on Desmos that it's 1, undefined, which makes sense, right? Because that's exactly what we obtain and how we form the equation. It should have a hole, so it should be undefined, because basically you're going to have a division by 0 or 0 over 0, right? That's what happens when you plug in that 1. That's why I crossed it out in order to solve for A. Okay, so that's essentially how you solve these types of problems, especially problems that have holes or discontinuity. It's more or less the same procedure if you're given multiple holes. Okay, it's just more tedious and repetitive. So that's all there is to it. And let me know if you have any questions.